Wish you all an amazing and a productive day ahead. In today's short video session, I will be doing one system design exercise and I have chosen to design Uber. Before I begin with an exercise, I would like to answer two very obvious questions. First one, how my system design sessions are going to be different from so many already available on the internet. And the second question, why am I even publishing it on the LinkedIn? Answering the first one, there are two reasons. First, uniqueness. Over a period of time, I have developed a unique way of solving problems, and I would love to share them with a wider audience. And I'm sure it will help build more perspectives, and the listener would be able to learn more better techniques from this session. Second reason, my content is minimalist, simple, concise, direct to the point, start with the heart of the problem itself. This will help listener focus on the most relevant and important pieces of this system design. Now, answering the second question, why am I even publishing it on the LinkedIn? Again, there are two reasons. First, I am seeking more opportunities in the open market, and these videos will help me reach more employers. And the second reason, I am open to join podcasts of similar kind where people from different expertise are coming together and speaking openly and sharing their knowledge and perspectives to build the future of products and services. Now I would like to describe the format of this session. We will begin with the core functionality. Once we are done with the core functionality, then we will add only one feature on top of it. Now the question can be, why adding only one feature, why not many? Well, because the whole agenda and the purpose of this session is just to describe how feature addition can happen on top of core functionality without breaking the core design and architecture of the application. Vice versa, how core functionality should be designed, keeping in mind that it will evolve in future. Once this much is done, we will jump to the non-functional requirements. Nowadays, there are so many non-functional requirements people discuss about, but we will keep ourselves focused only on one, and we have chosen scalability for this session. Although there are so many, for example, scalability, availability, durability, fault tolerance, cap theorems, monitoring and logging, but we have chosen only one for this session to keep it simple and concise. Now, I would like to elaborate this whole format, keeping in mind our specific use case of designing the Uber. So, what does core functionality would mean in this particular exercise? Core functionality would mean that a user should be able to send his booking request to our platform, and our platform should be able to respond back with a driver confirmation. That's it. This much will be the core functionality. And now, what kind of feature we want to add in this exercise? Well, I have chosen to add a feature of price negotiation. It means a user will quote his price to the driver, and user and driver should be able to come in the process of negotiation. And only after the successful negotiation, they would be able to confirm the ride, and the user would be able to use that ride. Now, what does scalability mean in our use case of designing Uber? Scalability would mean that millions and billions of users throughout the world should be able to use our platform to book their ride. It means our platform should be designed in such a way so that millions and billions of requests, if come at a single point of time concurrently, our system should not crash or it should not become non-responsive. It should still stay fast, responsive without any latency, without any delay. It should still confirm the ride for user under such load. Now let's begin with the actual implementation and the actual on-ground system design of this exercise. For this purpose, we will use draw.io and we will draw some diagrams. And we will start with a very minimalistic view. There is going to be one client application and one server application. And client will send the booking request to the server, and the server will respond back with the confirmation of the driver. Now let's have a look at how this request and response would look like. A sample request can look like this: user ID, is going to be the ID of that user who is sending this booking request, and then we will have from two, which are going to be the longitude and longitude of the location from where this user is sending. Now, how the response would look like? Would server be able to send back the confirmation immediately in a synchronous way? The answer is no. This is going to be an asynchronous application because millions and billions of users might be sending that request, and it is not going to be possible to confirm it back immediately because in real time server will be communicating with few more microservices, and they will be sending the notification to multiple drivers and getting one of that confirmation back. Hence, this will be an asynchronous application, which means the server application might be using a queue at the backend, and the response would look like this: a request ID. Now, this request ID can be used by the client application multiple times to get the status back from the server to know whether this request has been fulfilled, whether it is declined, if it is in progress, or if it is done and completed, then what is the ID of that driver and where is he located right now, so that the client application can track and communicate with that user ID. Which means our sample response of this status check can look like this. Request ID is the original request ID on which we are trying to communicate with the status application. Now the status can be any one of them, either it is in progress, accepted, and declined, and then if it is success, then we will have the driver ID and the location as part of this particular response only. Now let's dive deep a bit more behind the scene. Let's try to see what server is actually doing behind the scene in order to come up with the actual confirmation. Till now, server have responded with a response which have the request ID, which means he have not confirmed yet. And then we are checking the status back from the server by sending the request ID again and again to check what's the status. Till now, this much of communication is happening, but we want to reach till confirmation. Hence, we will be drawing to more microservices for this purpose and try to explain how server would be communicating with those two microservices. Let's call one of the microservices add find me all drivers. The purpose of this service would be to take the request from the server and come back with all the drivers which are in a particular radius from the location where the request have originated. Once the server will have the response as all the user IDs of the drivers which are located in that periphery, server will go back and communicate with another service, and let's call that a notification and confirmation service. The whole purpose of this service would be to get all those user IDs which server have got from the find me all drivers and respond back with confirmation of one of the user ID. Now these all user IDs are driver user IDs, which means this server will be sending a notification to all those driver IDs, and upon successful confirmation of one of them, it will redirect back as a response to the server, which again will redirect back to the client application. So how this request and response would look like, let's have a look at that. Now this can be a simple request. This request will originate from the server and go to find me all service. What this request would contain in a very minimalistic perspective. This will have the original request ID so that find me all services can figure out from which user it is coming and where is his location. And then we will be requesting a radius, a 5 kilometer radius. Find me all the drivers in this particular radius and limit the number of drivers till 10 in response back. This service will come back with a response which will have all these 10 user IDs in its response. And once server application have all those user IDs, it will communicate it to the notification and confirmation. And this will come back with only one user ID as a response, which will be communicated back to the client application. Now, so far, we are done with the core functionality of the system. Now we will try to add one feature, and the feature which we are going to add is going to be the price negotiation. It means a user will quote his price and we'll try to communicate and come in a process of negotiation with the driver. And upon successful negotiation, it will become the confirmation. In order to implement this feature, we may need to change our application, but we will keep the fundamentals intact as it is. We will only try to expand our core functionality to add this feature. So what changes we will be doing? There will be two major changes we will be doing in our application. One change would be to add price also in all the request responses, in as many request responses. And the second change would be to have multiple request responses between these client and server applications, because negotiation process may take certain number of steps here. In order to add price in all the request and response, we will expand our request model. So our new request model would look like this. Everything will stay as it is, only that we have added price also, which means this is going to be the price quoted by the user to the server, and our servers also will respond back with driver's price. So in this particular response status, we will add one more thing, which is going to be the price quoted by user. Let's say user have requested 500, but driver is saying 600. Then again and again, multiple times, this request response will happen. And upon final negotiation, upon acceptance of this negotiation by both parties, we will have the confirmation of the user ID, and then rest of the OTP and everything will be generated. So far, we are done with the core functionality and one feature addition as well. Now we will jump to the scalability perspective. In order to have this perspective, we will draw few more diagrams on the draw.io, because this is a non-functional perspective. This have very less to do with the actual application and more to do with infrastructure. Hence, we require a separate perspective and we will draw more diagrams. Okay, so we will have a very minimalistic view again from the scalability perspective also. So for this purpose, we have drawn one API gateway. The API gateway will serve the purpose of being the entry point for all the requests. This will stay in the public domain, while the whole infrastructure, rest of the things will stay in the private domain to keep everything secure. Now this API gateway will have all the requests, which means it will also help us protect from denial of service. It will do the whitelisting, blacklisting, rate limiter, and so many functionalities which usually API gateways provide. This request will go to the load balancer, and from the load balancer, it will be going to multiple server instances. Now, before I explain this architecture, I need to mention what all steps we need to do to make our application scalable. Well, there are two important things we need to do in our application to make it scalable, and that is to make our application stateless, and second, to containerize the application. Now, both go together. Stateless means none of the server instances here should save the information of the session or the user information, because they can be terminated after serving that request, and our application should stay stateless in that sense. In order to maintain the session or state of the application, we can use another service. We can call it cache, where we will save this session information. Now, Dockerization part, as I mentioned, why Dockerization would be required, or why containerization. Sorry, Dockerization is a unique way of containerization. We can even Kubernetize also, but we will use this generic word. Along with making the application stateless, we need to containerize the application also. Now, containerization means the whole application will be bundled up and given to a containerization service. A sample containerization service, for example, Docker, have a standard script which looks like this, as I'm showing it on the screen. We can use anything. We can use probably Docker or Kubernetes, or probably some other containerization service with other cloud vendors are providing. We will be using any one of them, and for that purpose, we will be bundling our application and giving a script file to that orchestrator of the containerization application. Once this much is done, our application would be ready to become scalable application. Now we can attach one load balancer after the API gateway. and the script file will be given to the auto scaling group, and this auto scaling group automatically spawn a huge number of instances of the servers which we have bundled already, as we have discussed in the previous step. Load balancer will be distributing all the requests on the API gateway to all the server instances, keeping the session somewhere on the cache service, and to distribute to reach a huge number of users in the world, we may use the CDN. The whole purpose of CDN would be to fasten up the request and response from the user location to our service location. Well, that's it. We are done with our system design exercise. Please post your questions and queries, and I will create another video to expand and go in more detail of any of the service which I have mentioned. Thanks a lot for watching. Bye.